Okay, now this video is for 6.6 arithmetic series. So what does a series mean? All right, so here it says a sum. So mean add all the terms together in the sequence. Now because the sequence is arithmetic sequence, then that means this arithmetic series. We just add all the terms in the arithmetic sequence together. Now, for example, this add them together is a series, and it's an arithmetic series because they have a common difference as D as 4. All right, so as I said before, the most interesting thing is to understand how this formula came about. Otherwise, this section has no meaning whatsoever to me because you just plug all these, how many is n? What is your first term? This is your first term. This is your last term. Or if you don't know the last term, but you know the common difference d, you plug them in, and then you can calculate the sum. So let me try to, show the proof. Now, before I start it, I want to show you this example. It says from 1 to 50. Okay, so positive integers. This is 1 to 50, also called consecutive natural numbers from 1 to 50. Now, there's a story. I often talk about the story to every single student I encounter. Now, this story is about Gauss. You must have already heard the name Gauss, who is one of the most famous mathematicians in history. He lived through the 1700s, I would believe, and he's a German. He's a math genius. So this problem, as a matter of fact, at that time, the problem the teacher posed to this 7-8-year-old in Germany, a small village, is to add all these numbers together from 1 to 100. And within a couple of minutes, Gauss got the answer. He said, that's this. All right. So, and the teacher said, what? Are you serious? Show me what you did. Well, all the other children will start from 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. No, he says, no, I don't do that. What I do is that I add 1 to 100 and add a 2 to 99 because there's a 99 here. And I add 3 to 98. There's a 98 here. So every single thing gave me 101. Now, how many 101 here? 50 101 here. So you are just using 101 multiplied by 50. And then that is your 5050. Look at how genius this is. So now take a look at what is this 101? What is a 50? So 101, because your sequence is from 1 to 100. So that means 101 means if it's from 1 plus 2 plus 3 plus 2n. That means this 101 is 100 plus 1, right? And then your 50 is 100 divided by 2. Now, therefore, this is from 1 to 100. So this 100 corresponds to here, and the 100 corresponds to here. So then if it's from 1 to n, that means it is n plus 1 multiplied by, this is n here, n divided by 2. So if we organize this writing a little bit nicer look, it means n multiplied by n plus 1 divided by 2. So any consecutive natural number from 1 to n, you add them together equals n multiplied n plus 1 divided by 2. This is what this Gauss person 300 years ago, just about, figured out at such a young age. So we benefit from his, sense of genius until now, and he is the ancestor for number theory. All right. So now let's take a look at how we can prove our, series here. So we got a1 plus a2 plus a3 plus to all the way to an. We can also rewrite it, or a1, of course, that's just a1. So we just use a to say that a is just a1, right? So then in this case, then a2 is a plus d, and a3 is a plus 2d. So this is all go to here. I do a different proving compared to your textbooks here. So what I do is that in this case, if I took a look at this one here, now how many d's are here? How many d's are here? So if this is the an term, you see this is the last term. So if this is an term, so that means the d is the first one did not have the d. So the d, how many d here? D has n minus 1d total together here. So this last one, sorry, what am I talking about? Sorry, this last one is the n minus 1d, but we have this 1d, 2d, 3d. So we have this 1d plus 2d plus 3d, now plus all the way to n plus 1d. So in this case, if I factor out the d, then I have 1 plus 2 plus 3 plus all the way to n minus 1. All right? So now, going back here, so if all the way to n is this one, now all the way to n minus 1, this will be, d is here, n minus 1 will be n minus 1 and n minus 1 plus 1 divided by 2. Now plus 1 minus 1, that's gone. So then this many d are together give me n minus 1 divided by 2 and multiplied by n multiplied by d. All right, so this many. Now how many a here? 1a, 2a, there's another a, there's another a, all the way. So there is how many a's? There is n of a, right? So then I add this one and this one together is my Sn. So my Sn is n multiplied by this many a plus n minus 1 multiplied by n divided by 2, and there's a d here. All right, so now here could be difficult for some of you. So let me say this. So now between na and this bundle, there's a plus. So what I can factor out, first of all, I can factor out the n. This is probably easier for you guys to see. So now I factor out the n. So then I have n here. Then I have a plus n minus 1 divided by 2, and there's a d. All right. So the next one is I also factor out this 2 out. Okay, so if I factor out the 2, n here, factor 1 over 2 here, so n is here, factor out the n over 2. Now, over here is a 1 multiplied by a. Factor out a 1 over 2, that becomes a 2a. You take a look at, you multiply back in, 2 and 2 cancels, will give you 1. So then this plus n minus 1 d. And that is your formula. Look at this. It's your formula. N divided by 2, 2a multiplied by 2a plus n minus 1 d. Exactly this formula. Now, I can also rewrite it. So how can I rewrite it? Is I can rewrite it become n this, and then this one I'm going to become a plus n minus 1d. Note, take a look at this. This one is the last term. This is the last term. So I use L for the last term. Therefore, the formula can be also changed to n divided by 2, the first term, plus the last term. Just like that. All right? Okay, so that is a formula. And then after that, I'm just going to show you just a couple of examples. So basically, you can see from the couple of examples, you can see if you know the first term, you know the last term, and you know how many terms in the sequence, you can just plug all these numbers in to calculate the series. Or you do not know the last term, but you know the common difference, and you know how many of here, and you again plug it in. So it depends which formula you want to use. Now, first of all, see, term, how many terms? 25. You got the first one, but you do not know the last one. Okay, well then we might as well just use this formula here, right? Because from this one and this one, you can calculate the common difference, which is d is equals to 4. Then plug this in, 4 is here. 25, subtract 1 because n is 25. And 2 multiplied by 11 is your first. And 25, yeah, you got it. All right. Now, here says that find the series, right? Find the sum. So now you don't have the term number. You do not know how many terms here. So you do not know, we do not know n. We have no idea how many is n, but we don't even need to know it. Or we can have another way to know it. It's because you have the last term is 100. So then what is your last term? The last term is the first term plus n minus 1d, right? So the last term is 100. The first term is 7. And we do not know the n. Okay, let's see how can we calculate the n. And then we know the d. Between them is 3. So then again, solving for n. Okay, first of all, move that over there. That becomes 93 equals to 3 multiplied by n minus 1 divided by 3 on both sides, divided by 3 on both sides. That is gone. And then that is 31. N minus 1 equals 31, then n equals 32. Okay, so n is 32, then we can use this formula. That will be just very easy. First term, last term is, we all know, and we know 32, and then your sum is this one. Okay, now summation, do not worry about it. I will do another video for talking about the sigma notation and the summation. This is just a different way to write it. And then last one, so the summation, don't worry about example 5. Do another video. And then this one is interesting. This one is the sum of the n terms. We know there's n terms. And write it out is that. Now ask us to find a common difference. So what I would do is I would want to show you, well, basically just another way to do this. Your textbook has this way, so you might want as well just take a look at this. This is easier, but I like my ways because I like things more abstract looking. So in this way, they try to figure out, okay, so two terms are together, and so your second term is that, and your first term is this, then you subtract them, and you got a 10. So this is a very easy, very straightforward. But what I like to do, you know what, forget about it, because what I do this, most of you would think this is a video is too long. So we don't need to do it. Probably find another chance to demonstrate it. So this also means between 8 and 29. 8 and 29 is what means. What does that mean? It means in between. So there should be 4 terms. Now, what is the in between the 29 and this one? So we would have this and this. So what do we do here? Then we have A1, our first term is 8. Then we have this plus D plus 2D plus 3D. And then your last term is the fourth term is this. So you can calculate the D. So after we calculate the D, then this one add on, so that is 15. 15 add on another 7, that is 22. All right, so this is pretty straightforward. Okay, well, this is my recording, and then please try to find questions to practice on. And as I said, it is a very good personal skill to be developed to know which question you should practice on. Thank you for watching.